Okay, so this evening, we're going to talk about visual testing and how we can use visual testing to improve the confidence that we have in our software by verifying visual changes to our applications. So that's me. I'm an engineer at ezCater. I work on mostly front-endy things like our marketplace. More recently, I've been working on our design system, which is how I ended up in the space of visual testing. For anyone who's still trying to guess my accent, now you know. I grew up in the UK, so that's why I sound a bit funny. So what's our testing story like today? So before we dive into visual testing, I'm going to take a little bit of a moment to reflect on where we're at with testing generally. I'm going to try and talk about my experience both at ezCater and more generally in the wider open source community. So all in all, we're actually in a really great place. As a community, there are loads of great tools for us to use, and they allow us to focus on what's really important, which is, at the end of the day, delivering value to our customers. So as important as testing is, there's always this question of like cost versus benefit. For every test that we write, we expect return on investment on that test. And not all testing requires an equal amount of investment. So some of you may have seen this before. This one's from Martin Fowler's website. This is the test pyramid. The test pyramid concept came about from Mike Cohen in his book Succeeding with Agile. And more recently, Ken C. Dodds has been talking about a slight alternation on this idea around the testing trophy. The premise is kind of similar. The premise behind both is really to kind of indicate where to spend your effort of investment. And it's based on the speed of execution and the cost of writing your tests. So it's a rough measurement of return on investment. So the shape of the pyramid or trophy indicates that suggested level of investment to maximize your return on investment. So for a clearer picture on like what this means for us at ezCater, I'm going to talk about the type of tools that we use for our testing at each level. And that's the cost scaling. So at the bottom, at the lowest cost, for us, we have TypeScript, which is our static typing to catch type errors and typos. Just above that, we have our unit tests. They verify our behavior of individual components with our application. We actually use Jest for running our unit tests. The level above that, we have some level of integration tests, verifying that several things work together. And we typically use the React testing library for that type of user-centric testing, where we're combining components together and verifying some behavior of the system. And then at the top of the testing trophy or pyramid, we have Cypress that's driving our end-to-end tests like a bot clicking through the application and recording actions that are taken. So all in all, a pretty great set of tools available in this kind of space. So the next question is, so what is visual testing? Like, where does that fit into this picture? What is the purpose of visual testing? Well, in essence, visual testing is just making sure that your app looks as you intended it would. Sometimes called visual regression testing. It allows us to compare the current state of our application with the components in a known good state. So it allows us to check that our pages render as expected in different environments based on the changes that we're making to our code. So this evening I'm going to take you on a little bit of a journey to like how we got to using visual testing at ezCater. So chapter 1 of our journey, we actually started out with a lot of untested visual changes. So I'm going to see if I can set some context there. So to prepare the scene, like how many of you like use CSS and JS to style your applications? That's a decent fair number of you. So the long and the short of CSS and JS is allows us to define or use JavaScript to style how our components look. And so those of you familiar with CSS and JS are probably familiar with this syntax. This is actually from Emotion's website, from their doc site. Emotion is one of the many CSS and JS libraries that's available out there. And what I really want to kind of draw attention to specifically here, if I can move over to this, is this logic here. So if I passed in a prop to my component called column, then I'm going to set this flex direction to column. So there's some visual behavior here. There's some behavior based on the prop that I'm passing through. I'm changing how I'm visually rendering my application. So for the longest time, finding a decent way to be able to test this that wasn't brittle kind of eluded us. And we took a variety of different approaches to try and tackle this problem. But for a while, we actually left changes like this just completely untested. And we tried to make ourselves feel better by kind of assuring ourselves that this type of code wasn't super valuable maybe, and like it wasn't going to provide us the return on investment that it would take to write the test to verify this behavior. But visual errors invariably happen, and they happen a lot. And when they do, they're not always harmless. I don't want to pick on United here. There are a couple of different visual bugs there that made this easy target, but the link that's at the top there, the GUI gone wrong hashtag on Twitter, is a good example if you want to check out a few other types of visual bugs like this. And visual bugs can block revenue. So you can imagine here that, like, if in this flyout here in the bottom corner, or on the bottom right, you can see we're cropping off, we're not showing the full content here. If to the right of this there were buttons for the user to interact with, we'd have no way of interacting with them because it's all cropped. So you can imagine, like, at ezCater, we spend a lot of time working on our call to action buttons, making sure that they're the right color. We do A/B tests for those types of things. And we spend a bunch of time on that to optimize conversion rates. So if a button was to render without styling, there'd probably be a big impact on conversions and therefore on our revenue. And particularly if the button's not clickable, then it's definitely going to make a huge impact. So how can we minimize visual problems like this? So that led us on to chapter 2 of this story, which is manual testing. And this starts out as being like the types of change, the types of tests that you run through when you make a change locally. Just these sanity checks that, hey, oh, is this still working? I'm just going to check this real quick in the application. And those small checks then evolve into more rigorous test scripts. Like, here's a spreadsheet of all these steps that you might take to follow to make sure that your application's still covered. And then you quickly realize that that's not going to scale. And manual testing is really spending money only to get one-time feedback. Yeah. So just to kind of visualize how time-consuming this type of verification can take, we're going to play a small game. So we're going to play Spot the Difference, and there are 5 differences here. So when you think you've seen all 5 differences, just raise your hand. A couple of hands. I keep them up. If you've spotted all 5. Okay, still going. So yeah, it's becoming obvious that, like, actually it's really a lot more difficult than it looks, even though that this is only a kid's game. Cool, so spoiler alert, here are the 5. So yeah, it's a lot harder than it seems. And so psychologists have a term that they use to describe the tendency people have to miss changes in their immediate visual environment, and they call that change blindness. And so you can imagine if you're doing your visual verification of changes in your app locally, you're going to run into these types of issues where it's hard to actually find all the differences.
There's actually another difference too. Yeah.
Oh, there is?
The fence doesn't look right on both of them.
Yep, there you go. There you go, 6 differences. Good spot. So that was clearly too easy. Nice segue. But you can imagine as more and more visual elements appear on the page, or the page is particularly long or complex, then this problem starts to become a lot more difficult. So how many of you are kind of familiar with this? So fun fact, in England we call this Where's Wally? Yeah, anyone see Wally? Or Waldo?
He drowned.
As fun as this is going to be, I'm just going to show everyone. He's up there. Sorry, folks. Cool. So you can imagine, like, visual elements is one way that this becomes more challenging. To make matters more complicated, it's almost impossible to try and scale that type of testing strategy across multiple browsers, across multiple operating systems. This is a tool called Browser Stack that allows us to log in from our browsers and emulate different environments or test using different environments. And this, what you're seeing here, is just the different Android devices you can test on. And there's dozens and dozens of other devices that we can verify. So if you imagine trying to do those visual changes across all of those, you'll end up getting a realization of how difficult this problem is. But just to really drive this home, we're going to do a little bit of math. And we're going to keep this simple. We're going to take the 5 most popular operating systems. Sorry, Linux. We're going to take the 5 most popular browsers. Now, it's not a complete overlap here in which browsers work in which operating systems. So we're doing a little bit of fuzzy math there. There are 2 screen orientations, portrait and landscape. So it's not actually times 2 because, again, you probably don't run portrait and landscape on all those different browser environments. There are 10 popular mobile device resolutions and 5 popular desktop resolutions. And so as these numbers start to combine, you realize that, wow, we're already at 325 different screen configurations just for a relatively basic setup. And we're not factoring in lots of different devices, lots of different device types here. So how do we verify this type of change? Well, there's hope. And the hope is computers are just way better at this than we are, as demonstrated by this video. So that brings us on to the next chapter of our journey, which for us was snapshot testing. And for a while, this was our go-to solution to try and tackle this type of problem. So what is snapshot testing? This is from the Jest docs. Snapshot testing, with snapshot testing, values are serialized and stored within text files and compared with a diff algorithm. So what does that look like? This is the type of test that you might write with Jest and snapshot testing. We're rendering a media component. We're taking a snapshot of said component. We're finding a button in that component and clicking it, and then we're taking another snapshot. And the Jest snapshot will then use that diffs of those stored snapshots and compare them against the new state when you make changes to the media component. So as you can see here, this is an example where we've evolved the media component. We've added a rel tag and a target tag, and the snapshot test is now failing. It's telling us, hey, there's a diff in the DOM here that's changed. So it's giving us an indication that there's a change to our code that's had some kind of outcome. And so you can take this one step further and not just test changes to your DOM elements. You can test changes to your CSS. And this was kind of great in terms of getting a heads up of a potential break. But you'll see with both this change and the last one that the test itself doesn't actually care what something actually looks like. It just cares that the code has changed. So you can imagine these tests being pretty brittle. And to take that further, if we use 2 divs around an element instead of 1, does that really change how something visually renders? Not really, but it's going to totally break tests that are authored this way. Does it matter to users if we use table for layout instead of flexbox? No, as long as it looks a certain way. And so these types of tests were causing us a lot of pain when we try to use tables for layout. we didn't really. What other problems did we kind of bump into? So we bumped into a few other types of issues here. So when tests did start to fail, we started looking at these tests saying, well, what is this mysterious snapshot? Where does it come from? What happens when I click that button? What should this snapshot actually look like? And Tomas Gold wrote a really good blog post on this that I'd refer people to. And he calls this the it should render disease, and that good tests are meant to act as good documentation for our code. So if you don't know how a component works and you can't tell from your tests, then your tests probably aren't that valuable. We started bumping into a bunch of other problems with our snapshot tests. So we mentioned that auto-generated output isn't particularly intention revealing. It's hard to figure out why tests have failed or how to fix them. We also ended up with a high number of false positives. So tests failing when we are trying to refactor our code. And when we're refactoring, that's where we want our tests to be the most reliable. And yet this was when DOM snapshots were the most brittle. It also required us to have a lot of discipline to go through our generated outputs and figure out why they were failing. Like, why did it make sense? And anyone who's used just Snapshot knows that if you press U, it just updates all the snapshots. So it really required a lot of discipline for us to not do that and actually look at the snapshots to figure out why things were breaking. So that wasn't really panning out quite as we had wanted, which led us to the next chapter on our journey, visual snapshots. So how do visual snapshots work and how do they compare to Jest's DOM snapshots? So visual snapshots actually take a screenshot of the UI in a good state. And what we're talking about here is like an actual like JPEG or GIF or PNG image of the user interface. We store that screenshot just like we would store your DOM snapshot in a Jest snapshot. We run the tests again after a code change. We compare the screenshots with a diff algorithm. And then we pass or fail the test based on some visual threshold. So just to visualize what that looks like, we've got an example here. And so in this example, this is from the Jest snapshot docs. You can see the left-hand side is the good state, the right-hand side is the current state, and in the middle there, we've got a big diff, or an image that's indicating where the diff is breaking. And so this is basically the computer telling us where Waldo is. Now, most visual regression testing tools like this integrate in the CI/CD pipeline, and they take screenshots of components in various environments, like real mobile devices, and then they report back to us these any visual regressions. So at ezCater, though, we actually try and favor getting feedback as early as possible in our development process. So to maximize the value of the feedback and minimize the cost of investment, we run those tests at dev time in a headless browser to catch regressions as they appear. And so I'm going to show you what that looks like. Can everyone see this? Okay. Okay, so this is a super important form. It's really, really important for our business. So as I'm developing on this page here, I actually make a mistake, and I change our primary button to being a destructive button. Oops, I've broken it. And so the browser's preview is showing the diff here, and our test is, ooh, you know what, I did that totally wrong. Hold that thought. I didn't take the snapshot in a good state first. Apologies. This is what happens when you do a live demo. Okay, taking the snapshot in a good state. This is the form in a good state, and we've generated a snapshot. It's relatively quick to run, and locally we've got this snapshot that looks exactly like our browser output that represents the image that we've captured. Here's the PNG. And so as I'm back to breaking my code, oops, this is a destructive button. I save my change. You can see in the browser preview here, oops, my test is now complaining. I get a a message telling me that it's 1.9% different, but more importantly, I get this diff output. And the diff output here, if I can highlight this, shows me the good state on the left, the bad state on the right, and then highlights the area that's changed. So it really makes it obvious, like, what has broken in your application visually. And yeah. So in addition to the fact that this is really calling out the visual change, you can imagine this doesn't break if I've added different divs to render my screen, if I'm using tables instead of Flexbox for my layout. As long as the form renders consistently, the visual diff still continues to work. So advantages they have over the DOM snapshots. It's easy to see why the tests have failed. When we pair that with the tools in our toolset, just using like a git diff, we have a clearer picture of how the change that I've made locally affects the component. It's eliminated these false positives. The visual test is only failing if there's actually a visible change to the output. And we can still run this in a real browser and identify cross-browser issues. So at ezCater, we wanted to take this one step further. So if good tests act like documentation for our code, can we actually get a head start by using our documentation as tests? So this is our design system at ezCater, and we've documented all the various different states that our components can be used. So a lot of companies that have design systems have doc sites like this. Ours is written in Markdown, but as you can see here is we've got a destructive button showing the button in this destructive state. Disabled state, we've disabled out the button, and a loading state. And so we're documenting, oops. This is not a live website. If I click on here, I can actually see the how I put my application into the, how I define that component to put the application to this state. So our docs already show us the combination of props necessary to render a component in a certain state. So wouldn't these exact conditions make a great test cases to demonstrate that our application is behaving as it should, or at least initially behaves as it should? So today we actually author our doc site with Markdown. You can see on the left we've got the Markdown for the page, and the actual docs are generated from that. So Markdown on the left, and we use Gatsby to generate the web page from the Markdown. And so we're also then using these fenced JSX code blocks using docz to turn them into live examples on our doc site. Which is super useful because it then gives us an ability to use our doc site to make changes to our components to see kind of how things work. So we're driving that capability from this Markdown. But wouldn't it be really cool if we could take that same Markdown and generate these visual regression tests from them? And so that's what we do at ezCater. We've open sourced this tool called Soja to do that for us. So we take the Markdown and we actually generate our docs from that. I'll make these slides available at the end if you want to have links and stuff. Cool. So when we actually introduced this change in our design system at ezCater, it allowed us to remove like thousands of lines of code. So you'll see literally thousands of lines of code from tests that we didn't have to maintain anymore because we were already verifying this was the visual state of our application before and the visual state afterwards. And so we were able to do this change without losing, improving the confidence in our test suite, but without losing any test coverage. And so going forwards, our default template for testing components in our system includes visual snapshots for each example that's in our documentation site. So this is providing us out-of-the-box test coverage, ensuring that a component looks as it should when it's initially rendered on the page. And so this has saved us a whole bunch of time and money, as we can focus our efforts on writing tests to demonstrate that a component behaves as it should once we interact with them. And it phases out all those initial tests that we had to write about verifying the initial state. So, woohoo, for saving money. Okay, so it's not all rainbows and sunshine. There are some challenges, so I want to go over some of those challenges that you might bump into if you're going to implement visual testing for yourself. So here's the first one that we bumped into at ezCater. Animations. So animations are a really great way to kind of enhance your application, but they can play havoc with visual regression tests. So if you imagine I'm trying to take a snapshot of this, depending on the timing of the snapshot, that may or may not work. So how do we work around that? How do we solve this problem? So this is what we do at ezCater. We currently actually disable the animations. You can do smarter things than this too, like use CSS to set an animation a certain way through the progression, so that you're taking a snapshot of the animation at a deterministic state. But for most cases, this is good enough to get you your first pass through. The next hurdle that we ran into were different operating systems rendering content differently. So in particular, anti-aliasing techniques vary depending on the operating system you're on. It even goes as far as sentences breaking at different points depending on what engine that you're rendering with. So that was our next hurdle. And there are luckily a bunch of different ways that we can solve this problem. So the first one I'm going to talk about is using Docker as a way to normalize the environment that you're running in. Docker basically allows you to host a different environment within your current operating system. So if I'm running on my Mac, I can run Docker to host another environment, so I can run my tests in that environment, and someone else can use Docker to run the tests in the same environment. So they produce normalized, consistent snapshots. There's a plugin that's been created by the team at Smooth Code called Jest Puppeteer Docker that integrates Docker with Puppeteer. So you can run your tests in a standardized environment regardless of operating system. Another approach, and this is one that we use at ezCater, is running Puppeteer inside of an AWS instance. So again, this is basically a way to then normalize the environment that you're using to actually take the snapshots. But that takes you part of the way through the visual testing story. If you're interested in testing across different environments, using the visual snapshots to verify this behavior works on iOS, it works on Chrome on a desktop, then you can use a tool like BrowserStack. BrowserStack actually have a snapshot API, a screenshot API that you can call into to ask BrowserStack to take snapshots of a certain web page in various different environments, and it gives you screenshots back. So what other hurdles did we come up with, did we bump into? So another hurdle that we bumped into is dynamic content on our pages. So this, you can imagine if I'm testing Amazon.com, this part of my page is an ad. It's something that can then break my test because I don't have any control over that in my environment. So some of the tests that you might write might contain this dynamic content, causing text and images to change every time the page gets refreshed. This is actually a problem that we don't face in testing our design system at ezCater. We actually have full control over the props that we pass to our components. And then components using static data and static props are so much easier to test than components with dynamically changing data in the background. So it's not typically something that we've bumped into that often. I'd also typically recommend that you don't try and take snapshots of whole pages like this. I'd definitely try and recommend keeping screenshots as small as possible, individual components where possible, rather than the full web page, as it just minimizes the number of visual elements that can cause your screenshot to change and your tests to break. But that being said, let's have a look at some other solutions that are available to us. So the first one that I'll give a nod to is Jest's mocking. So by mocking out dynamic content and replacing that dynamic content with static content, we can make our tests deterministic. It allows us to control our tests to run in a predictable and reliable way. There is a cost associated with that, though. The cost there is that setting up mocking requires a lot more setup for your tests. Another possibility is better tools with better algorithms. There are a couple of different tools that I'll call out here. There's a tool in this space called Percy. There's another one here that I've mentioned called Applitools. This screenshot is from Applitools, and it actually allows you to mark different regions of your page as being potentially a region that you're not interested in, so you can ignore sections of your page. Going further to that, some of these tools have capabilities to overlook common environment normalization issues such as text anti-aliasing, so that your tests will only break if there are differences that are meaningful to you. So again, with this Applitools tool, there's these options for, actually I'm interested in this region of the page, but I'm only interested in layout changes. So that gives you a little bit more granular control over what types of changes you're interested in as part of your visual regression test. So what does the future for visual testing look like? So algorithms to detect changes are always improving. Computer vision technology, which is the same kind of technology that powers self-driving cars, and it allows them to recognize objects. That same technology can be used to power our snapshots without the overhead of calibration and training and tweaking or setting thresholds. And those same processes can then also power AI-assisted bug diagnosis. So instead of having to use that Git diff that I was talking about earlier in conjunction with your visual snapshot, we can actually get these tools to analyze the code change that we make and the visual diff in conjunction with each other to actually highlight specific visual changes, just to speed up that bug fix process. So what's the takeaway? The takeaway today is visual testing is making sure that your app looks as intended. Visual bugs aren't just cosmetic, they block revenue, and visual testing can be a great addition to your testing strategy. So thanks very much.